Hello and welcome to this webinar on designing precast concrete joist floor slab systems with CYPECAD. My name is Sonsoles. I'm a civil engineer and I'm part of the technical department here in Cype. Our main focus today is, of course, going to be the designing of precast concrete joist floor slabs as part of the new features of the version 2025C. But we're also going to review all the different kinds of slabs that can be analyzed in CYPECAD. So please do not hesitate to ask all your questions on the chat. We'll be answering them all, if not during the webinar. If the answers are not covered during the webinar, we will make sure to reply to all your questions. So let me unshare my camera just for you to better see all the content that we want to share today. And CypeCAD is, when we Google CypeCAD and we go into the first link that appears on the search, we will find that CypeCAD is one of Cype's key softwares, and if this software carries out the analysis and design of structures for both building and civil works that are subject to vertical and horizontal loads, as well as fire exposure. So the main focus of today's webinar is, of course, a very specific kind of floor slab systems, which is this beam and block precast concrete beam and block system. Some of the advantages of this kind of flooring is are that speed of construction and the minimal on-site work. So, of course, whenever we are speaking about precast and off-site manufactured elements, we can see that whenever the beams and the blocks are delivered, we can very rapidly assemble this kind of flooring, and that it makes it, that's one of their great advantages. Also, offsite fabrication in controlled conditions leads to consistent qualities, and we know that precast concrete has excellent compressive strength. Yeah, so it makes it ideal for depths or for quite heavy, ideal for quite heavy loads, right? And this is only one of the kinds of floor slabs systems that we have in CyPECAD. So let's take a brief look at this project. So we are going to hide the slab for a minute, because we're also going to talk about inside CyPECAD about these kinds of slabs. But let's not forget, although the webinar is about precast concrete joist floor slabs, we also have a steel joist floor slabs. We also have timber and trusses joist floor slabs that we can analyze in CyPECAD, as well as other kinds of floors and slabs, which could be these composite. Let me hide the SPIM so we can better see this composite deck kind of flooring, as well as these other. If we come here to the information and we ask for the information, we also have waffle slabs, hollow core plate slabs, and of course flat slabs. So let's take a look at the software. We wanted to make use of this time of this webinar to actually insert a model a little structure from the very beginning, so you can take a look. This is the main interface of CYPECAD, and if we click here on new and we start right away a new model, the first thing that the software asks is whether we want to link our project to the job that we're creating to a BIMserver.center project. So what is this BIMserver.center? What is it? Well, all the images that I showed before here, you can see that we are at BIMserver.center. This is our BIM platform, and it's an optional workflow, which means that you can share whenever you design on CypECAD, you can afterwards share to a BIM open BIM platform, and that is optional, as I said, so we can unlink ourselves from the BIMserver.center if we want to, and we're right away going to insert an empty project. The first thing that comes up is the general data of the project, in which we'll have to select the codes. CypECAD has many codes around the world implemented. If you're not sure whether we have your specific code implemented, you can find that information on our website. If you Google Cype.com and you come to solutions and implemented codes, you can search by program and check whether we have your code implemented or not. So coming back to our job, we can select where for this job we're going to select all the Euro codes, and we're actually going to accept the general data of this project. And so CypECAD is divided in 4 tabs. The first would be up on the bottom left bottom part of the screen. You can find that the tabs are column definition, beam definition, results, and counterplots. They're actually designed in order, so they're meant to be following that order. In this first tab, column definition, we can enter the groups and the columns, as well as share walls and starts. So we're actually going to start inserting a new floor. This floor is going to be 3 meters high, and it's going to have a certain live loads and dead loads that will be applied to the entire floor. When we finish, by default, the software comes with one floor. So whenever you're adding floors, remember that you only have to add the extra floors that you want to have. And by entering the columns, we will find that the columns that can be inserted in CypECAD have multiple type of sections. We have reinforced concrete columns, both rectangular, circular, and you can actually design and create any kind of section for your concrete. And we also have steel with multiple sections that can actually be inserted in the software by accessing a library of sections. We have, for example, Indian standard, Korean standard. We have plenty of libraries of sections from all around the world. Here, another kind of section of the columns is actually timber. And of course, we can also find in CypECAD composite sections. So both concrete and steel can be done in all these multiple kinds of formats. Today we're actually going to insert concrete columns, and I'm going to start right away by inserting the first column. So one good trick to insert either beams or columns is actually that when you press any key on any key number on your keyboard, this calculator of coordinates comes up. So let's actually insert the first column in 0, 0 coordinates. And another great tool to insert any elements are actually that we have the possibility to insert templates. So how is that done? When we come here to edit templates and we add, for example, any one that we have previously created, so we can insert it in our job. I'm going to then right to the right, we have the possibility to make this DXF or DWG files visible. And right to the right again, we have the possibility to activate the object snaps. So by clicking, for example, on center and zooming in to snap the template, I can easily start modeling the um, the columns. If I make any mistakes, all of these options are there to make our job easier, so we can come back at any time, and we make sure to zoom in enough. We will have inserted all of our columns in no time at all. Actually, in this same column insertion menu, we will also find shear walls. We can insert either shear walls or directly walls on CYPECAD, which we are going to do in a minute. And when we are done inserting the columns, we can, and of course the groups, we can continue with the beam definition. So right now you can see that we have only inserted the columns. We can change groups using these arrows right here. And here in this first floor group, I'm going to come here to walls and we're going to enter a new wall. I'm trying to cover all of the elements that we can find in CyPECAD very quickly so you can see how easy it is to insert all of these elements and how quick we can actually insert a structure. So in the columns, in the walls, we will find reinforced concrete, plain stress walls, as well as reinforced concrete blocks and masonry walls. In this case, I'm going to insert a reinforced concrete wall, which can have various foundation types. In this case, I'm going to insert a strip footing, but let's point out that foundation beams can also be selected. And when I click accept, I can right away insert columns whenever I want to. I also have the possibility of many tools, such as extending these walls. And of course, the footings will be inserted as we insert the wall, but not in these columns. So let's stop for a minute here in foundations to actually select what kind of foundations can be inserted in the software. We can see that we have footings, okay, as well as pile caps, and we can also insert strap and tie beams. So let's insert right quick these footings to make a more complete structure. Okay, coming back to the upper floor, we are going to go to the beam menu. Here in beam menu, we find define beam, and we can select through multiple kinds of beams. Of course, concrete beams of all kinds, dropped, T-beams, even variable section beams, lattice beams. We have pre-stressed beams, as well as foundation, of course, and also steel beams, like with the same sections that we saw earlier for the columns, with the same a library of sections, and here timber beams as well. We're going to insert the flat beam, and now we're going to change the width and complete our very simple structure. We also have other kinds of tools for beams. For example, we not only for beams, but here you can choose the orthogonality to actually create right away the geometry. By clicking on any of the beam options, we can, for example, extend the beams to whatever length we want, or here in this other icon, we can easily delete the ones that are no longer good for us. And also, there is a family of beams called non-structural beams. These are great for defining the perimeter of the floorings, so we can then insert the slabs as well as the columns. We can again press any number on our keyboard, and this calculation of coordinates will appear. And again, coming here to delete, we can start deleting whatever ends of the beams are not necessary anymore, as well as the parts of the walls. So how easy was that to insert? We have now a very simple, but very quickly we inserted that geometry. And we can now start with today's matter, which is slabs. Basically, if we come here to slab and panel manager, we will be able to enter panel. So floor slab systems would be the first and the main focus of today's webinar. But let's first cover all the different kinds of slabs that could also be analyzed here in CYPECAD. Before we like this floor slab system is actually a new feature, but before we had these reinforced joist floor slabs and pre-stressed joist floor slabs, which is more simple. They were also manufacturers, beams and blocks, but we could insert it from a library too, but they didn't have all the ULS checks that our new floor slab systems are going to have. We also have in-situ joist floor slabs, so without any joist, we can also select to insert whatever block, and by selecting also the compression layer thickness, we will have those kind of floors. Also, we have a steel joist floor slab and open web joist floor slab, as we saw in the BIMserver project, as well as the timber. All of these three were inserted, and they're as easy as this, also selecting the block and the beam, or selecting whatever timber section and all the other parameters. Continuing with the selection of slabs, we have also hollow core plates, which are actually kind of similar to our joist floor slabs, but we have it here. Also composite decks, both form deck and composite decks. Waffle slabs, we can select from a library of waffle slabs, and we can import it right away. Also flat slabs with selecting the depth, and matte foundations. This is very important because previously we saw that foundations could be footings and pile caps, but in CYPECAD we can also analyze matte foundations. Okay, so by entering this first floor slab system, we can come here to add, and this is what you will find when you first try to insert today's matter, which is the precast concrete beam and block systems. The software actually access a database called Open Beam Database. here, if we Google Open BIM database, you will see that it's actually database of manufacturers offering their products in digital format. So we can then use these elements that they offer their products inside Cype softwares. So very important, the catalogs that we can download for these um, joist floor slabs are actually right here. If we accept the conditions, we will be accessing those libraries. But you may be wondering, so what if we don't, like our manufacturer is not on the list? Well, here we have you're missing a catalog where you can actually um, fill up a form in which we can then contact the manufacturers and actually implement or add those catalogs that you use inside the software. uh, I have selected these two manufacturers. I have just downloaded their information and we're going to use it right quick. So I'm going to click here on finish. And I selected two because this is one difference from what we had before. Before, we could only select beams and blocks from the same manufacturer, but now we can select the beams from one manufacturer and the blocks from another, making it more flexible. And if we give it a name, this slab is actually going to have a 4 centimeters normal thickness of compression layer, this right here. And this option of changing the interaxis of the single joist assembly, these kind of assemblies are sometimes editable. So we can we can select a different interaxis as long as it meets all the requirements. And if we exceed the interaxis that we can that are actually available or compatible with the joist that we have selected, the software will warn us. So let's place back this dimension. And we're actually going to now insert the flooring by clicking on accept and clicking accept again. I'm going to come here to this to define. And when we click on this surface and then we select a beam, we will have inserted the floor. When walking through this panel manager, we find that we can actually the leading panels are is the option that creates opening. Here, this change insertion point. Whenever we insert the floor, maybe the beams are not placed where we want them. So if I select the floor and then select any point, okay, in this case, I'm going to make it right by this right beam. The beams are placed wherever we want them. And here in the change the layout, we can actually make these beams parallel to one beam or the other. And by clicking on panel data, we can access at any time the data of the slab. So by coming here to more data, we not only have the previously selected beam and block, with their information, but we can also access some very important complementary information, such as what is the concrete volume poured on site, what is going to be the volume of this concrete poured on site by square meter, and what is the self weight of this solution, this system, by square meter too. So if I click here finish and we're done consulting the information of this slab, we have a possibility to copy the slabs. So once we have inserted one, we can copy this slab and place it everywhere else. The This makes it possible to for the beams to be continuous, okay, and not only simply supported. By clicking here on minimal moments, we can access the minimal moments that are applying to the job. These that can be changed for each specific slab. And so by user coefficients, we can come here and change these coefficients. Isolated spans. So these kinds of flooring usually are simply supported, right? So we have to take into consideration that maybe they're not going to be completely simply supported, which means that they're going to have maybe or to consider a minimum moment just in case. We can select different for, of course, an isolated span, the end span, the intermediate span, of course, the cantilever. When we come here to code check with job coefficients and we finish, those job coefficients are actually selected right here in project, floor, slab options. We find the minimal lengths to of top reinforcement in joist floor slab. The minimum moments to cover with slab reinforcement. These are the general data for the job, and as we saw, we can assign different coefficients to each slab. Coming back to the panel manager, we just have left in the fixity coefficient, which it makes sense that if this part is going to be in cantilever, maybe we leave the fixity coefficient of these two slabs being 1, so we can have it continuous. We will see it when we consult the results, but maybe this cantilever part can be continuous with this one, but maybe we want to make this other part of the beams simply supported. So with this option of fixity coefficient, we can say 0 and assign it here. So this part of the floor slab will be simply supported and this will be continuous. Also, this fixity coefficient is applied to all the edges of this slab, but if we want to have the control of which side or which edge we are actually fixing or not, we come to beams and other options. And here in fixity, we can actually select the fixity coefficient for the beam faces. So when we come here and we select that this face of this beam is actually going to be with a coefficient of 0, that will make um, these two parts simply supported and not continuous. More things that I have to tell you are that we can actually enter double joist. So at any time, if we click here and I'm not going to do it, but if we click here and we click on any joist, we can double them. And I think without further ado, if we take a look at what we have inserted right now, we can actually analyze this job. So if I click here in analyze and including foundation. I'm going to click accept, and in very few seconds we're going to have the results for this simple structure that we have inserted with precast concrete beam and block systems, as well as the results for the columns, the beams that we have inserted, the walls. And actually, one of the greatest things that we have in the software is the amount of results. So coming here to this result tab, we right away see something more than we saw in the other tab. So I'm actually going to start showing the forces over the beams, because the joist, because we can here in envelope forces in joist, we can actually draw the diagram force over the force diagram over the joist, so we can clearly see that as we left the fixity coefficient being 1 in this, this is one continued beam, but in this case, you can see for by the moment diagram, we can see that this other joist that I placed with a fixity coefficient of 0 is actually simply supported in this part, and then it continues, this other part with the cantilever is actually continues. So we have access to these envelopes, and of course we can also consult by a simple load case or by combination. And we can not only draw the moments but also the shear force diagrams and the torsions, and as well as displaying their values and showing us across the forces diagram the results. So that is one of the things that we can consult, but coming here to the joist results, we can start from the very beginning by clicking here on views. This allows you to select what is actually visible on screen. So if I unselect this top reinforcement, of course, the top reinforcement disappears, and we can concentrate on this mesh that the software analyzes. And stopping here for a minute, I didn't say anything about which code or standard the software uses for running this analysis. So let me share right quick that the standard that is implemented is actually EN 15037/1. This is a European standard, and it applies to every national annex of the Eurocodes. So if the Eurocode, if you have a national annex of the Eurocode in your country, you can actually use, and it applies this standard. And so the mesh that this software analyzes can be changed by clicking here in joist and edit distribution reinforcement. And the one that it selects, it already verifies all the checks according to this standard, but we can choose to add more reinforcement if we wish. This reinforcement is the tables for the reinforcement are here in project general data, and coming here to this by position icon, and in slab, waffle, and joist floor slabs, if we click on the rib top reinforcement, we will have the access to the base reinforcement table of these precast concrete joist floor slabs. So by default, this table of reinforcement comes with the same reinforcement in both directions. But if we unclick this option, we can select the different reinforcements in the different directions. I'm actually going to leave it like this, but just in case you want to select your own or complete according to whatever is available to you, you can complete those reinforcement tables. We can choose to hide that information of the mesh by unselecting here in joist and joist views. We can come here to the bottom and unselect this base reinforcement. And if I click accept, that will disappear, and we can actually choose at any time to uh, make visible the top reinforcement again. So um, of course, this reinforcement can be edited. Here with bottom reinforcement and top reinforcement, we have tools for matching them, for designing it and insert it by default, for editing it or modifying its position. And we'll actually do it because I want to show you the actually great aspect of this new feature, which is the code checks. So according to the standard that we previously saw, the EN 15037/1, the software comes up with the code checks, the ULS checks for these joist floor slab. And if we click in any beam of the beam and block system, we can actually access that full analysis or the full I will say it, the full report or the code check of this joist floor slab, meaning that it checks the normal thickness that we have used for this slab, making sure that is compatible with the standard. It also analyzes if that mesh that we have just taken a look at actually complies with the code checks, and if it's enough or not, it will show us. Then we have the check for the bending moment. These checks are actually very, very well described. Actually, it's all the justification of the code check for the standard. So here we see the bending moment with all of its justification, and we can also consult the shear case code check. It also analyzes the deflections and the total in both active and total deflection, and we can actually limit that. We can establish those limits, and we're going to see it in a minute. So let's continue with the justification. The cracking control is also checked and verified, in the stress limitation of both the passive reinforcement and the active reinforcement, as well as the stress in the concrete of the precast joist. So this report can be printed completely by clicking here on view the full report, and this will show you the slab that you have inserted with all the checks, and you can export it to multiple formats. If we go back a little bit, I would actually like to point out that these same code checks can actually be consulted by checkpoints, which means that we not only have results for the entire beam or the entire floor, but we also have access to the ULS and ULS checks of this beam. So by clicking in any beam, we can actually consult these code checks by point, because here in this beam exactly, by the way, if we make the top reinforcement invisible, we will see that the software displays with different colors the different beams. That means blue would mean that it verifies it complies with all the checks, but consulting the code checks of this beam, for example, we could see that it has a warning on the stress limitation of the concrete of the precast joist. So by the column, the color warns us. And why I remember this is because if we actually check this same joist, sorry, by points, we may find that almost every point verifies all the checks until we find the one that doesn't. So it's very important that whenever we come here to the code checks of the full joist, and the software will point out here, it says which part of the standard we can find this code check, but also it will point out here that the worst case forces for this exact code check are actually produced at the 5.6 meter of this beam. So when we come here to joist and ULS checks points, we can actually select by point, and here in the upper left corner, we will find the location, and this is actually point 5.6, but maybe clicking here, this is the location of 2.8 of the joist. Speaking of the length or the points of the joint, the software has automatically selected the length according to the available lengths in the library that we selected previously. Remember, these are precast concrete joists that came from a manufacturer, and they're manufactured in certain lengths. So whenever we have the span of we know the length of our span, we know that the software has selected this length of joint, but if we come here and show all lengths, we will see the available ones that there were. And here they are, the ones from this series of FT25 that we selected. And actually, what the software does is it checks here in project floor slab options. We find here the design of precast concrete joist floor slab systems, and the software lets us select a minimum and a maximum support length to the joist. So with this data, the software, and according to the length of our span, the software will automatically find which joist had to select from the series. So coming back here to the joist, we can consult the deflections, and actually you can see them on screen, and we could actually also see them on the code checks. So where are these limits of deflections established? If we come back to project and floor slab option, we find here the active in total long-term deflection for precast concrete joist floor slab systems. So if we come here, we can actually select the period between the removal of the soaring of the execution of the element for which the active deflection is verified. So we can have the control over that, as well as the dead loads progressive applying. And so here is where we actually have that long-term then definition of the limit, and here the deflection limits for precast concrete joist floor slabs. We can actually establish the total and the active deflection. This menu has other aspects of joist floor slab options. If you're missing any configuration or any settings of the joist floor slab, such as these parameters, you may find those options in this menu that we found in project and floor slab options. And without further ado, I will actually like to represent the top reinforcement because we are going to consult now the results. So the software can actually come in here to reports and the drawings. The outputs that we can take from CYPECAD are that we can easily generate multiple kinds of plans. The software generates them automatically. So let's, for example, select the detailing of the columns, which we didn't consult the results for, but we have access to the floor plans too. And coming here to drawing type, we find frames drawing too. So let me print this drawing right quick, and we will check where we could check the results for the other elements. So by clicking right there, we saw how easy it was to generate and how quickly it generated all of this information. And if we zoom in, for example, in this plan view of the floor plan in which we inserted this slab, we can see that it comes with the top reinforcement, the number of the beam, it comes with the information of that mesh that the software placed. And we actually have more data in these boxes. You could consult the information for the floor, and also we could come into these floor plans are actually a little bit editable. So if we come here to the floor plan and we edit it, we can actually select that we want to see the reinforcement layout and the quantities summary to add to this floor plan. So we click accept and generate the drawing again. We click on yes, and the information will be there. And what I mean by that is that this this information of the detailing of the reinforcement and this summary of the steel used in this floor will come up. We can not only have for like plans of drawings of the plans, the photo plans, but we also can consult, or the software generates automatically the drawings for the every beam. Okay, we can also consult here the detailing of the columns, which by the way could be edited just like we did on the joist. Here in the results tab, we could have come here to beams and edited the beams, and we have access to the results as well as the ULS checks, of course, for every span. Of course, again, listable, like we can generate the complete listing for the report. And we actually have many tools to edit the reinforcement of this beam, and which is the one that is actually coming up on the drawings that we just saw. Also for the columns, we have results. So if we come here to columns and shear walls and I edit any column, we will take a look at the table of the columns. Again, the forces over the columns could be consulted by load case or by combination. We can come to the 3D view of the reinforcement, which is the one that is actually shown in the drawing that we generated. So we have plenty of results, not only for the slab that we inserted today, but also for every other element, and not only graphic like drawings, but also reports. So if we come here to reports, about the joist floor slab reinforcement the joist floor slab that we inserted, we come here since there are actually precast in manufactured and off-site manufactured. The only thing that we will maybe have to consult is the quantities of the joists that could easily be printed, as well as the quantities of forms that have been used to generate these slab. Also, we can consult the reinforcement used in those mesh and that top reinforcement that we saw earlier with the summary of the total amounts of this. And we have many more reports. I recommend that you check them out. And I think this is what I wanted to show you about the modeling and the verification of these kind of slabs and every other type of slab that can be inserted in CYPECAD. So if you come to Google and actually search for one of the frequent questions, you can actually start using this software. The free access to the version, okay, is evaluation version. You have the steps here. So if you Google how can I use the Cype programs for free, you will find these steps. Remember that this version is 10 days limit, not necessarily consecutively the 10 days. So I invite every one of you to try out the software. And of course, you can contact us with further questions about the product at Cype.com. Thank you so much for your time and being here today with us. See you on our next webinar.